According to NEC 314.16a, the volume of a box shall not be less than the volume of the conductors within the box. Conductors include any wire, cable, or raceway that carries current. To accurately calculate box fill, first, identify all conductors within the box. This includes the home run conductors, branch circuit conductors, and conductors associated with any devices within the box. Remember to include all current carrying conductors and equipment grounding conductors. In the example, the initial count is as follows. Firstly, a home run with 6 current carrying conductors and 1 ground, totaling 7 conductors. Secondly, a branch with 2 current carrying conductors and 1 ground, totaling 3 conductors. Thirdly, a branch with 6 current carrying conductors and 1 ground, totaling 7 conductors. Fourthly, a duplex receptacle with 2 current carrying conductors and 1 ground, totaling 3 conductors. The initial total is 7 plus 3 plus 7 plus 3, which equals 20 conductors. However, the NEC provides exceptions that allow certain conductors to be excluded from the count. NEC 314.16b3 allows the following to be excluded from the count. Firstly, conductors of a size AWG14 or smaller used for branch circuits of not more than 120 volts. Secondly, tap conductors of size AWG10 or smaller used for tap circuits of not more than 120 volts. In the provided example, the duplex receptacle conductors meet this exception. Assuming the duplex receptacle is wired with AWG14 conductors on a 120 volt circuit, you can subtract the 3 conductors associated with the receptacle from the total count. Therefore, you subtract 3 conductors from the total of 20, resulting in 17 conductors that need to be counted for box fill calculations. Finally, NEC 314.16a also states that the volume allowance shall be based on the number and type of conductors in the box. For boxes containing only the same type of conductor, the volume allowance is determined using the following formula. Volume allowance equals K times N, where K is the volume allowance factor for the given conductor type and size, and N is the number of conductors of the type and size. The volume allowance factor depends on the size of the conductor. For example, the volume allowance factor for AWG14 conductors is 2.0 cubic inches per conductor. The volume allowance factor for AWG12 conductors is 2.25 cubic inches per conductor. The volume allowance factor for AWG10 conductors is 2.50 cubic inches per conductor. The volume allowance factor for AWG8 conductors is 3.0 cubic inches per conductor, and the volume allowance factor for AWG6 conductors is 5.0 cubic inches per conductor. In the example, all of the current carrying conductors are assumed to be AWG12 or larger, since they are in a box. The volume allowance factor for AWG12 conductors is 2.25 cubic inches per conductor. Therefore, the volume allowance is 2.25 times 17, which equals 38.25 cubic inches. This calculation provides the minimum volume required for the box to comply with the NEC. If the calculated volume exceeds the volume of the box, a larger box must be used to ensure compliance. Since 38.25 cubic inches is greater than the volume of any standard box that could house this many conductors, it is not necessary to physically measure the box to ensure compliance. In summary, to correctly calculate the conductor count for box fill, firstly, identify all conductors entering the box, including home runs, branch circuits, and device conductors. Secondly, apply any applicable exceptions from NEC 314.16b3 to exclude conductors that meet the exception criteria. Thirdly, determine the volume allowance factor based on the conductor size and type. Fourthly, calculate the total volume allowance by multiplying the volume allowance factor by the number of conductors. Lastly, ensure that the box volume meets or exceeds the calculated volume allowance. This comprehensive approach ensures compliance with NEC regulations and promotes safe electrical installations. Remember that proper box fill is crucial to prevent overheating and potential hazards associated with overcrowded electrical boxes. Always refer to the latest edition of the National Electrical Code for the most up-to-date regulations and requirements. Understanding these principles and applying them diligently will result in safe and code-compliant electrical work. The NEC is updated periodically, so staying current with the latest changes is essential for all electrical professionals and anyone performing electrical work. The calculations outlined above are based on general principles and common scenarios. However, specific situations may require additional considerations or interpretations of the code. Consult with a qualified electrical inspector or engineer if you have any questions or concerns about box fill calculations or any other electrical code requirements. Always prioritize safety and compliance when working with electrical systems. Incorrectly sized boxes or improperly installed conductors can lead to dangerous conditions. Taking the time to perform accurate box fill calculations and following the NEC guidelines will help ensure a safe and reliable electrical installation. Furthermore, consider the practical aspects of working with conductors in a box. Overcrowded boxes can make it difficult to make connections and can increase the risk of damaging conductors during installation or maintenance. Using a box that is adequately sized for the number of conductors and devices will make the job easier and will help prevent future problems. In addition to the volume allowance, also consider the physical space required for devices such as receptacles, switches, and lighting fixtures. These devices take up space within the box and can affect the overall fill. The NEC provides specific rules for accounting for the volume occupied by devices. Be sure to include these considerations in your box fill calculations to ensure compliance. Remember that the goal of box fill calculations is not just to meet the minimum requirements of the NEC, but also to ensure a safe and reliable electrical installation. Taking a conservative approach and using a box that is slightly larger than the calculated minimum can provide additional space for making connections and can help prevent future problems. In addition to the conductors and devices within the box, also consider the presence of any cable clumps or connectors. These components also take up space within the box and can affect the overall fill. The NEC provides specific rules for accounting for the volume occupied by cable clamps and connectors. Be sure to include these considerations in your box fill calculations to ensure compliance. Furthermore, remember that the NEC is a minimum standard. Local codes or regulations may impose additional requirements or restrictions. Be sure to check with your local building department or electrical inspector to determine if there are any additional requirements in your area. Staying informed about local codes and regulations is essential for ensuring compliance and avoiding potential penalties. In addition to the technical aspects of box fill calculations, also consider the importance of good workmanship. Neat and organized wiring within the box will make it easier to troubleshoot and maintain the electrical system in the future. Taking the time to properly train conductors and secure connections will help prevent loose wires and other problems that can lead to electrical hazards. Good workmanship is an essential component of a safe and reliable electrical installation. Furthermore, consider the long-term implications of your work. A properly installed electrical system will provide years of reliable service. However, a poorly installed system can lead to costly repairs and potential hazards. Taking the time to do the job right the first time is always the best approach. Investing in quality materials and following best practices will pay off in the long run. Remember that electrical work is not just a job, it is a responsibility. The safety of people and property depends on your knowledge, skill, and attention to detail. Take pride in your work and always strive to provide the highest quality electrical installations. In addition to the information provided above, consider the impact of voltage drop on conductor sizing and box fill calculations. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction and can reduce the efficiency of the electrical system. The NEC provides guidelines for limiting voltage drop. When calculating box fill, be sure to consider the impact of voltage drop on conductor sizing. Larger conductors may be required to minimize voltage drop, which can affect the box fill calculations. Furthermore, consider the impact of ambient temperature on conductor ambiguity. The ampacity of a conductor is the maximum amount of current that it can carry safely without overheating. The ampacity of a conductor is affected by the ambient temperature in which it is installed. The NEC provides correction factors for adjusting conductor ampacity based on ambient temperature. When calculating box fill, be sure to consider the impact of ambient temperature on conductor ampacity. Higher ambient temperatures may require the use of larger conductors, which can affect the box fill calculations. In addition to the technical aspects of box fill calculations, also consider the importance of communication and collaboration. Working with other tradespeople, such as carpenters, plumbers, and HVAC technicians, requires effective communication and collaboration. Coordinating the placement of electrical boxes and wiring with other building systems can help prevent conflicts and ensure a smooth construction process. Furthermore, consider the importance of continuing education and professional development. The electrical industry is constantly evolving, with new technologies and regulations being introduced regularly. Staying current with the latest developments requires a commitment to continuing education and professional development. Attending seminars, workshops, and online courses can help you stay informed about the latest trends and best practices in the electrical industry. In addition to the formal education and training, also consider the value of hands-on experience. Working on a variety of electrical projects can provide valuable insights and skills that cannot be learned in a classroom. Seeking out opportunities to work with experienced electricians can help you develop your skills and build your confidence. Remember that the electrical industry is a challenging and rewarding field. With dedication, hard work, and a commitment to safety, you can build a successful career as an electrician. Always prioritize safety, follow the NEC guidelines, and strive to provide the highest quality electrical installations. Your work will make a difference in the lives of others. In addition to the specific details covered in this narration, it's crucial to understand the broader context of electrical safety and code compliance. The NEC is not just a set of rules, it is a comprehensive framework for ensuring the safe and reliable operation of electrical systems. The code is developed and maintained by a team of experts who consider the latest research, technology, and field experience. The goal of the NEC is to protect people and property from electrical hazards. By following the NEC guidelines, you are contributing to a safer and more reliable electrical infrastructure. Furthermore, consider the role of the electrical inspector in the code compliance process. Electrical inspectors are responsible for enforcing the NEC and ensuring that electrical installations meet the minimum safety requirements. Working with your local electrical inspector is essential for ensuring compliance and avoiding potential problems. The inspector can provide valuable guidance and feedback on your work. Remember that the inspector is not your adversary, they are your partner in ensuring a safe and reliable electrical installation. In addition to the technical and regulatory aspects of electrical work, also consider the ethical responsibilities of an electrician. As an electrician, you have a responsibility to protect the public from electrical hazards. This responsibility extends beyond simply following the NEC guidelines. It also includes using your knowledge and skills to identify and correct potential safety problems, even if they are not explicitly covered by the code. Your ethical obligations should guide your decisions and actions in every aspect of your work. Furthermore, consider the importance of community involvement and advocacy. The electrical industry plays a vital role in our society. Electricians are responsible for powering our homes, businesses, and infrastructure. By participating in community events and advocating for responsible electrical policies, you can help promote the importance of electrical safety and code compliance. Your voice can make a difference in shaping the future of the electrical industry. In conclusion, box fill calculations are an essential aspect of electrical work. Understanding the NEC guidelines, applying the appropriate exceptions, and considering the practical aspects of working with conductors in a box will help ensure a safe and reliable electrical installation. Remember to prioritize safety, follow the NEC guidelines, and strive to provide the highest quality electrical installations. Your work will make a difference in the lives of others.